Good morning, Assalamu alaikum. This is a live school Nushara campus. Today we are going to have another topic which is regarding electron affinity. So students, what electron affinity means? Affinity basically means love or like. Electron means electron. So the word electron affinity means love or likeness to get electron, right? Before going in detail in our topic, we should first know that there are two rules. Rule number 1 is duplet rule, and rule number 2 is octet rule. So according to duplet rule, the element tries or tends to get 2 electrons in its valence shell. For example, this is hydrogen. So hydrogen has 1 electron in its outermost shell. What hydrogen wants to do? Hydrogen wants to get at least 2 electrons in its outermost shell so that it can complete or it can obey the duplet rule. So from outside the body or outside the element in the atmosphere or in its surrounding, wherever it finds an electron, it will capture that electron towards itself. For what purpose? To complete its valence shell, that is to follow the duplet rule, right? Except it, the duplet rule is also followed by helium, because helium has a maximum of 2 electrons. So as helium is already following or obeying the duplet rule, it doesn't gain any electron nor it loses an electron, whereas in case of hydrogen it can gain electron as well as it can lose the electron. Either it will have both of the electrons in its valence shell, either it will like to be in a positive form, that is it will give an electron and it will get a positive charge. Similarly, what an octet rule is? Octet rule is to have a maximum of 8 electrons. Oct means 8, dup means 2. So octet rule means to have a maximum of 8 electrons in the valence shell. For example, we have an element oxygen. So the atomic number of oxygen is 8, whereas atomic mass of oxygen is 16. So we have to deal with atomic number. This means it is having 8 electrons and 8 protons, right? So by writing its electronic configuration, we will get 1s2, 2s2, 2p6. 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are altogether 10 electrons. So how many electrons do we need here? We need 8 electrons, right? So 2, 3, 4, 5, 6, 7, 8. This means its valence shell is having only 4 electrons, right? So this is K. K is equal to 2, whereas both of the second shells are L. This means L is having 4, 5, 6 electrons in its orbit, right? So by drawing its sketch, this is nucleus. Let it be the nucleus. How many protons do we have? Protons are 8, neutrons are 8. Your first shell, which is K shell, that is having 2 electrons, whereas the L shell is having 4 electrons. 1, 2, not 4. L shell is having 6 electrons. 1, 2, 3, 4, 5, 6. Right? Okay. Now, according to octet rule, how many electrons should be in valence shell? There should be at least 8 electrons. So 1, 2, 3, 4, 5, 6. But it's having 6 electrons. So what will it do? It will capture 2 electrons from its outer surrounding, right? It will capture one of the electron from outside towards this side, whereas it will capture another electron to pair this lone pair, a lone electron. Okay. So then what will be the case? 1, 2, 3, 4, 5, 6, 7, 8. It will have 8 electrons in its outer shell. Okay, now look here. So this tendency that they want to get the electrons from outermost into their outermost shell from the surrounding, that is called as electron affinity. But that's not the exact definition of electron affinity. It's the likeness for electron affinity that they want to complete their octet or their duplet rule, right? But what's the case? The case is that whenever an element gains an electron from outside, it loses some amount of energy. So what you have to keep in your mind, that whenever electron goes inside an element in an orbit, at that time the energy goes out from the element, right? Electron in, energy out. And this minimum energy which goes out from the element, that is called as electron affinity. So if you look at the definition of electron affinity, this is the minimum amount of energy released when an electron is added to gaseous atom of an element in its outermost shell to form an anion. Now what does this anion means? It's called electron affinity. It is represented by Ea and it is assigned in negative values because it is an anion, okay, and expressed in kilojoule per mole. Look here, this electron affinity, that is chlorine. Chlorine's electronic configuration is 2, 8, 7. For shell K, shell is having 2 electrons. L shell is having 8 electrons, where shell M is having 7 electrons. So it wants to get at least 8 electrons in its outermost shell. So whenever an element gains an electron, what happens? It gets a charge of negative. Why? Because, see here, there were a total of 8 protons and 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, right? But when it got those 2 new electrons, now how many electrons are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 electrons, whereas protons are 8. So 8 and 8 will be cancelled out, whereas it has 2 extra electrons. This means that it will gain a charge of -2. Because why are we writing this minus here? That is because it has more electrons. How many electrons? 2 more electrons, right? Okay. So oxygen, after gaining 2 of the electrons, it gets a charge of -2. This means that it has more electrons as compared to the original oxygen atom, right? Another thing, that when it got the electrons from outside, so we said that whenever electrons come in, so energy goes out. This energy is called as electron affinity. So the electron affinity of chlorine is -348.8 kilojoule per mole. This kilojoule per mole is its unit, whereas this minus sign here, this minus sign shows that the energy is being given out. The energy is being released. Now it has less energy, right? So when it has less energy, this means it will be more stable now. Alright, now look at the case of oxygen here. Oxygen is having 6 electrons in its outermost shell. So first it will gain 1 electron, so it will have -1 charge, and similarly here the electronic configuration 2 remains 2, whereas 6 has been increased. Now there are 7 electrons in its valence shell, right? And the electron affinity is -141 kilojoule per mole. This minus shows that energy is released from the element and electron is being added here. But now if you look here, what happened? See, initially the oxygen was in this form. There were 2 electrons, and there were 1, 2, 3, 4, 5, 6 electrons, right? But here in this case, there are 1, 2 electrons after gaining one of the electron. It's now 1, 2, 3, 4, 5, 6 and 7 electrons. So here in this case there were less electrons as compared to this case. As there are now more electrons, so it will not gain that electron this much easily because of these electrons' repulsion. Electron and electron, both of these electrons will repel each other, whereas both of this electron and this electron will repel each other. So in this case there is more electron repulsion. This means that now it will absorb energy. Now it will need energy with the income of an electron. Why do it need the energy? That is because of the presence of more electrons than before, right? So in this case there was less repulsion, so it released some energy to gain some electron. But here in this case now there are more electrons, there is more electron repulsion. Electrons repel each other because of having same charge. So in this case it will require energy, or it will absorb some energy to gain another electron. So if you look here in the case of oxygen, so oxygen -1 will gain an electron to get a charge of -2 and to get the electronic configuration of 2, 8 is following octet rule, and so its electron affinity is plus 844 kilojoule per mole. Why is this plus over here? That is because that now this income of electron will require energy. For what purpose? To overcome the electron repulsion, right? Okay. So I hope it's clear now to everyone. Let's see what are different factors which affect electron affinity. So it's nuclear charge, its atomic radius, shielding effect, and electronic configuration. You saw how electronic configuration affects it. If the valence shell is not completed, if the valence shell has less electrons, it will like to gain more electrons, so that electron affinity would be increased. Shielding effect means the presence of more shells over here. Look here, what is shielding effect? Shielding effect, for example, we have a shell. This is period 1, period 2, period 3, and this is your period 4. So in period 1 there is only 1 shell, whereas in period 2 there are 2 shells. In period 3 there are 3 shells. In period 4 there are 4 shells. Now look here. In this case, where there is only 1 shell, the nucleus has more effect over here. The nucleus has more attracting power. So wherever it finds an electron, it will just capture towards itself. Whereas in this case, the nuclear charge over the valence shell is very less because of more distance, right? So that is why we say that those elements which have small radius, which have less shielding effect. Shielding effect means the presence of shells. So here is only 1 shell. There are 2 shells. That is the shells in between the nucleus and the valence shell. This is the valence shell. It's the nucleus. So there are 2 shells between them. In this case, this is nucleus. It's valence shell. So here's only 1 shell between them, whereas in this case this is nucleus and this is your valence shell. So there are 3 shells in between them, right? So which is having more shielding effect? This will have more shielding effect, whereas the first group is having less shielding effect, right? So we say that small radii, less shielding effect, and more nuclear charge or more nuclear attraction will have more electron affinity, right? So if you read over here, that is the same case. Smaller atomic radii, greater nuclear charge, and poor shielding effect have usually high electron affinity. So what you have to do, read them. I explained all of these to you. In this case, hydrogen is having, leave the hydrogen. Hydrogen is having 72.8 electron affinity, whereas cesium is having 45.5. This means that hydrogen is having more electron affinity as compared to cesium, right? Whereas if you look over here to fluorine, fluorine is having 328 more as compared to hydrogen. Why? That is because of its smaller size. So fluorine is having most small size or the smallest size of the periodic table. That is why its electron affinity is more as compared to hydrogen and as compared to cesium, right? So that's enough for today. Have a good day. Bye bye.